We're good. Okay, well, I want to talk about 3D printing, and the idea is to have something that's going on here at school while you're continuing to work on your apartment projects. It's fun. What can I say? It's nice to see 3D things coming from your 2D drawings, which is sort of what we do here. And let me talk a little bit about the material that we'll be working with. There are a bunch of different kinds of 3D printers. Some that use this kind of filament, some that make them magically appear in vats of rosin. Some use lasers to melt thin layers of gold or titanium or stuff together. But this is called PLA, and it's short for polylactic acid. And all of these are all plant-based. Pretty much any plant byproduct, whether it's straw left over from farming, or hemp stalks left over from growing marijuana and making rope, or tree bark or sawdust, anything like that can be sort of fermented and reasonably benign catalyst added to it, and it turns into a polymer, which has the property of this stuff of being thermally, what's the word? It acts like a thermoplastic. You can melt it, shape it, and it cools off, and it holds the new shape. But we won't be using any of the ones that are actual petroleum based at all. Those are there, and they're waterproof. These are not. These end up being somewhat water absorbent. So you don't want to use these for cups or aquariums or something like that. But pretty much all the 3D printing processes start by, and this is what we'll do today, taking the sort of concept of a 3D object, slicing it into very thin horizontal layers, and then using a bunch of different technologies to then stack those layers back on top of each other with one material or another. And we're using what's called, the process is called, 3D printing is the whole field. This is called FDM for filament deposition, something or other. I don't even know, but 3D printing. And you can make all sorts of things. Again, so what the 3D printers are is they're essentially hot glue guns that are highly, computer controlled, but basically drawing your object line by line, layer by layer, with what amounts to sort of hot glue, and it is hot. And they just gradually build up, and they've got the final object. And here are just a couple. So you can start thinking of things that are essentially flat. You just give them a little thickness and print them. And all these, remember, print from the ground up, from the bed of the printer coming up. And then, or you can take things like this and make them and assemble them together, 2D things, to do stuff that hasn't. I think these are stunning. I really like them. Little buildings like a box. You could use this for storing stuff in when you're done with the class. Another whole building here done, pretty much in one piece, I think. I did a couple things I made when I was practicing. I made some furniture with the working drawers. Yeah, you can admire these if you want to. And this isn't exactly how furniture is made. I had to create some little grooves here and ridges here for these to slide in on. There's something analogous in an actual drawer, but I can't model little tiny bearings and stuff, so we did it this way. There's also the option you can see here with the printers of having a smooth face, or if you want the horizontal faces to be sort of made irregular, it can get sort of a wood texture there. So there's some options along that line. This was a bookcase and display thing for somebody's project a couple of years back. Because these build from the bottom up, if I'd tried to build it like this, I would have had to support that whole top, which makes a lot of extra stuff coming down. You can remove it all right with the clippers and files and stuff, but it's easier just to print this way. And then all that has to get supported is those top two ones. And what we'll be working today for our sample file will be this really lovely AutoCAD Revit locker room bench, which was printed this way, and it could just print right straight up, no supports, no nothing needed. So we'll start with this. And then Keith has said he has Revit models of the houses in Florida that were 3D printed by on the site with a big, it's like a concrete coming. Have you seen those on, YouTube and stuff? They sort of do this sort of a thing. And I don't have that file yet, but I think that'll be a fun thing to do maybe next week. And then I'm trying to set up a visit over to one of the two speed. Well, there's the AMIST facility here on the corner, which has a room as big as a gym full of different kinds of 3D printers. And that's where I'd really like to go first, just to see the different types available. They have ones like this, but bigger. And then speaking of big, at the University of Maine in Orono, I was set up to go visit them this summer, but then broke my ankle. They have the world's largest 3D printer, and back here we can build into a volume of about 10 by 10 by 8 inches. Up there, it's 32 feet by 96 feet by 24 feet. And the nozzle's like this big. And it can do a boat, pieces like this. It's pretty amazing. And the interest in Maine is they have something like 100 million tons of wood waste a year from the forest industry, sawdust and bark and chunks of logs that they get used. So the idea is you sort of mulch all this, turn it into 3D printing fuel, and 32 by whatever I said, that you could like 3D print 3 tiny houses at the same time. Take them to a site on the back of a flatbed truck and put a roof on them, and then you've got some houses. So they're thinking about that kind of stuff. Those pretty much all still need to be waterproofed on the outside because it's a wood-based product. But it's pretty amazing stuff. So what I want to do today is, well, here's the whole process. Just to outline what's going on is we're starting with the Revit model, the bench, and from Revit we're going to export it to a STL file, which stands for stereolithography, and that's just a representation of the outside surfaces of it. Just what are those planes that form the outside surface? And then we take this into our slicing program, which is called Slicer, and that's where we actually do the chopping, and we can control the layer height, whether we want the nozzle to go slowly and carefully or go a little faster. And then that's going to kick out what's called a G-code file, which just means generate geometry code. And what that is this is directly instructions to the printer to go to here and then skip over to here and put some plastic down there and skip to there and put some there and do that, and then come back here and start again and layer up and layer up. So it's very, it doesn't make any sense when you're looking at it. It's just streams of numbers. And then we put that into the printer. There's nothing to do at the printer. I got it. I came in over the weekend and calibrated them, so they all should be working pretty much correctly. So for us, the first thing we're going to do is load this program, is install the Slicer program. So what we want to do here is open a browser, and we're going to go over to Prusa, P-R-U-S-A 3D.com. And these are in headquarters in Prague. Really amazing company. You can Google tours of their plant and stuff to see what's going on. But one of the interesting things is their printers are made with a lot of 3D printed parts. Of ours back here, everything that's orange is 3D printed. And in fact, we had something break or a part to put on, and we could just get the STL file of that part and 3D print it on one of the other printers and put it in it, and then the other printer worked. So we're just going to go to software, and Prusa Slicer 2.9.3 is what we're going to download, and then just going to run that file. English. And we're just going to accept all the defaults here for where it's going to be happening. And on this check, I have already downloaded the drivers that update the printers. We don't need to do that. We're just going to check this first one, just the program itself. Unless you have a 3D printer at home and want to do it, but 3D, that's fine. Just accepting all the defaults. Okay, you can close your browser. Oh, I clicked this twice or something. Sorry. Finish. So something I mentioned on the very last page here, is there any number of websites where you can just download STL files that people have published? And we'll take a look at those. And this is saying, do you want those just to open right away in this program? You might as well say yes, because we don't have any other program that we're going to be doing it for. And one thing I neglected to do was to create the STL file that we're going to be using here. So let's get into Revit. Now, we shall open Revit. Everybody open Revit, please, because you'll be doing it this way at home. And it can be any file here. Okay, let's say you've got your summer vacation home here, and you want to put a locker. You've got a locker room bench in there. Let's go to Component, Place Component, Load Family, and you can do this with the Autodesk family or whichever. But I want to go to Furniture, Seating, Bench, Locker Room. This could be in your apartment, doesn't matter. Now, right now, this is a 2D view. And if we export from here, regardless of format, we're going to get 2D objects. We need to get into a 3D view before we do our exporting. And we need to turn off everything except one bench. The XTL export routine exports whatever is visible on the screen, whatever 3D entities are visible on the screen. So I think the cleanest way in this sort of situation, let's say that you've designed a library and you designed some custom seating, and you've got one of those that you want, there's 5 of them or something, and there's one of them that you want to 3D print one of them. The easiest way to do this is to select it, select the one you want to print, and then down here, Revit's bottom line where the little eyeglasses are, click on the little eyeglasses and say isolate element, and that'll simply turn everything else off. Just a temporary turn everything else off. So now that I have that single object done, when the export routine kicks in, it's just going to grab everything, and that's all that's there. We go into File, Export, CAD Formats. This is here on the middle of first page. And we want to go down to STL for the stereolithography file type. Different printers can accept this information in, this is the ones and zeros format. This would actually have looking like numbers, we know them format. And these printers can accept either one. I just leave it on binary. We've got a choice of resolution. If you want to print something curved quite quickly, you can pick coarse resolution just to get a sense of what it looks like, or you can click over to fine, and it'll be a much smoother surface. I'll just leave it in the medium. And then sort of I'm sorry about this, Alina. All my assumptions are working in feet and inches and scales that way. just because this is America. We could be exporting this fractional inches and millimeters, centimeters, but stay with feet and fractional inches. And then when we get it into the slicing program, we can say use feet and inches, and they're all lined up. So feet and fractional inches. There are printers. You see ours have two spools up there, but only use one at a time. There are printers that you can put up like 5 or 6 different colors, and it switches back and forth. So preserve colors is export colors. If you want to be able to separate things out that way, we can't do it, so don't bother. And say save. And it's going to ask you for a location for this to go. And we're going to be creating 3 different files. There's going to be the STL file and the G-code file, and then eventually one sort of saving it as a project. I would like to have all 3 of those together in the same folder, so we don't have them all, some on one drive and some on your desktop and some who knows where. So here in my documents folder, I'm going to right click and create a new folder. I'm just going to call it 3D bench. And then go over and then double click on it to make that my current folder. And then I'm going to give this actual STL file a name. You see STL is the kind that we'll be seeing down here. So I'm just going to call this bench here. It defaulted with the name of the project and the name of the view and that kind of stuff, but bench is what I want. Okay. So we'll have bench STL. And now since we've got that temporary hide isolate, it's saying, are you sure that's what you want to do? And I'm saying, yes, I did the isolate on purpose. And now we're done with Revit. We've created the STL file we need, and we can print it here, print it at home, put it on the internet. Other people can print it. So let's see. So here we're in the middle of getting towards the bottom of the first page. We haven't installed the printer. That's why. Sorry, I beg your pardon. We need to go to configuration wizard. Sorry, beg your pardon. We should have done this even before this came in. So configuration wizard. Yes. And here we can say next. I think we can we do this? Let's just say next. Okay, we only want to look at these fixed filament. Anyway, the FF ones. These are the rosin printing ones. We just want to look at Prusa. That's all we've got here. Check that, say yes. Next. Okay, and now this is like all of their printers. I want to scroll down quite a ways till we get to the MK3 family. And we just want to check. It's the one that's checked for me. I don't know for you guys, but it's this one, original Prusa, i3 MK3S and MK3S Plus. Is that showing up? Okay, and that's the only one we want. It's worth noticing that you can control the width of the pass by actually physically replacing the heated nozzle on these printers with one that's either finer or coarser. But we're just going with the one that came with it, which is that one. And none of these matter, just that's the only one we want. And we'll say next. And we don't need to do anything custom here, just say next. And the only ones I really want to check here are Prusa PLA, and then their slightly higher grade one, which is Prusament PLA, Prusa filament. And pretty much everything we're going to buy here will be one of those 2. You can get carbon fiber ones, you can get fiberglass, you can get wood filled ones, have actual, little chips of oak or something in there, but just those 2. Prusa PLA on Prusa Mint PLA. Good enough. And you notice all these other companies, um, we've got some stuff from ColorFab that somebody ordered for some reason. It's all basically the same stuff, but they have slightly different portions of the additives to them and the colors and the elasticizers and stuff, which means that they behave slightly differently. And the printer needs to know about that to know how to build with them. But this is all I want for now. Next. Check for application updates. Update built-in presets automatically. Sure. Allow built-in downloader. Sure. Let's say yes. This will keep track of exactly where each file came from in case we need to know it later on. And here I'm going to check both of these. There are other slicing programs, one called Cura, and there are a bunch of others, but since this is the only one that we're going to use, every time like we double click on an STL file, it'll open the slicer, which makes sense. It's a clean way to work. Next. We can switch back and forth up here between simple. Well, let's leave it as simple and call it a day. And we can specify actually how big the thing is. We can either specify the scale factor, or we can just say make it 14 inches long or 12 inches long. So let's use that as let's check that as an option for us. Now, did this open up better? Okay, we actually have some choices to make. Okay, because we have a printer at the other end. Let's just leave it what it's set for, 0.15 millimeters quality, Prusa PLA, original Prusa right here. What happens if I just tried to print it, slice it and print it right now, the way you get around here is just hold the left mouse button down and press, and you can rotate. It's not the middle one like AutoCAD. I wish you could change it, but you can't. But it would, as the little hot glue goes back and forth and back and forth and back and forth here, it'll work fine on the legs, but then it's going to have to start trying to draw this corner here out in space, and just going to droop down. And it's going to come over to here and try to go from this leg to this leg, and it's just going to droop down. So we can print supports if we want, which will sort of fill in underneath there with a lot of extra stuff that we can cut away. Or we can think, is there a better orientation for this on the print bed where I won't have to print any supports? And as it turns out, yes, there is. And that's what this toolbar over here does. I mean, we can just grab this guy and move it. Okay, you don't really need this tool, except it gives you explicit X, Y, and Z coordinates. We can scale the same way, but what we're talking about is rotating. So when we hit the rotate button, those move axes turn into rotate axes. So you can see I've got a green one that'll flip it end to end, and a red one that'll flip it this way. And I'm just going to use the green one. And when I start using that, if my cursor is out here on the outside, I can just do it in any increments I want of increments of degrees. If my cursor is here on sort of where the minutes are, I do it in 5-degree increments. If I do it here, it clicks into 45-degree increments, and in here, it clicks into 90-degree increments. So I'm just going to rotate it a full 180 degrees, let go, and it'll drop it right back down onto the platform. If for some reason something hasn't dropped down quite level, you can sort of auto level it. If it's 2 degrees off, just to snap it into place with this guy, but it's hardly ever necessary. Well, now it's pretty well ready just to slice. All this is the same. We don't need supports because we've cleverly turned it upside down. So what we do now is slice it. Hit slice now. And in the wink of an eye, the software has figured out those all those layers and all the little tiny short sections it needs to do. If you drag this one, we can see those individual layers, and your mouse wheel will zoom you in. Okay, we sliced it. So we've got two sliders here, and this one lets you work down through the, and then within each layer, you can use this slider to see the path that the nozzle will be following. If you got some sort of question about it. And what we see here with the wavy stuff is those layers, it's just crazy to make them solid. So usually they're filled up with any of a number of three-dimensional lattices that will fill space and hold up the top surface, but be essentially, 75 or 80% air. Okay, so cute little guy. And it's color coded, so you can see that the purple is solid infill. Well, the orange is the outside perimeters. The yellow is just inside that. The purple is just inside that. So you can sort of color code to see what each thing is. And then the red is, you can do it up from the bottom as well. Oh, this is two sliders. Interesting. Basically, the tops, bottoms, and sides will all be two passes thick, and then it'll fill in inside there. If you're making something that needs to, let's say you want to hold, make a bracket to hold an axe on a wall, you might make that 4. We can, in the settings, we can make that 4 thick, so it just becomes stronger, and maybe do a thicker infill, a denser infill. But we're not doing that right now. Okay, so once you have the thing sliced, your printer and this kind of stuff, we say export G-code. And this is what's actually going to go to the computer, to the printer, sorry. And I'm going to stick it in that same folder. And what it does is, this is useful here. It says, here are the settings that were used to create this set of instructions. It's the project called Bench. We're using 0.15, 0.15 millimeter layer thickness. So that's fairly fine. It's for PLA. It's for an MK3S printer, and it's going to take 1 hour and 45 minutes to print. That seems like a long time. So let's say cancel that. And let's change the scale of this. So we have 2 modes here. We have the slicing mode, and we have the sort of getting ready to slice mode. I'm going to go back to the getting ready to slice mode, where we just see the object as an object, not as layers. And I want to scale it here. And how do I do that? I've clicked on the object. That's good. Okay, and now we have scale factors. And if you look at your, if you look here, that means this is going to print over here, see 100 on this. That means it's going to print at 1 inch equals a foot. And, this is, if I move this over, this is 8 inches. So I presume that bench was an 8-foot bench, something like that. So if we want to say, let's print it out so it's going to be at 1/4 inch per foot, which is 0.25 or 25, sorry, 25%. And I really want to lock these together so it doesn't get stretched. And that looks just too small. Yeah, that's tiny. So let's make it 50, which would be 1/2 inch per foot. And so that's going to be basically as long as one of those squares, which is this big. Big enough? Yeah, okay. Sounds good. We'll take it. If we wanted it to be like a little bit bigger, I know this will be right for 1/4 inch equals a foot. Going into a model, or 1/2 inch equals a foot, a model there. But let's say I just wanted it a little bit bigger. I can just increase its actual size. So this is 2 inches right now. 2 inches. I can make this 2.25 inches. And it'll just get bigger. I mean, the whole thing will just scale up X, Y, and Z. Let's do that as long as we're at it. So there it is, a little bit bigger, but not huge. Let's slice it again. And we can tell from down here, our sliced info, it'll take 36 minutes to print instead of an hour and 45 minutes. So that looks fine to me. It's been sliced. So I'm going to export the G code again. We did it once. I'm going to do it again. Oh, here it is. Oh, I didn't do it, but I'm going to this time. So it's saying me the bench. It doesn't give me everything. It doesn't tell me the scale and that kind of stuff, but it does tell me the 36 minutes one. Save. Okay, it's been saved. At this point, there's just a file, a G-code file that we're going to take over to the printer. The printers only take SD cards, not USB. And the reason is that USB devices can have on them self-installing software. You know, that when you plug it in, it makes changes to your drive or to your computer. And Prusa didn't want that happening on their computers at all. So they decided to use the SD cards, which are just a list of files. They're not ones that can execute. It's just a different way of storing information. So we need to get this file onto an SD card. And we have a couple of adapters for these. Does everybody have like the USB-C jacks on their? Okay, well, at each of these computers, we have a USB-C to SD card adapter. So you just plug this in, plug it in, save it to this drive, which will show up as like drive D or E or something in Windows. Pull it out, plug it in here, and go. So let's just have one person do that. Are you ready to go? Let me give you a card. This is where things get a little flaky because we're starting to deal with little pieces of stuff. But each of these has an SD card in them that should stay there. If you want to have your own, you can certainly get it. I picked up the last few at Staples that were $10 a piece. If you go to CVS, they're like $30 a piece. It's like, that's insane. So we can use these, or you can buy one from me for $10. But anyway, so we're just going to plug this in here. Autoplay. So this is coming in as drive D. So let's get into File Explorer, and let's go to wherever those files were. Down Documents, Bench. And then this bench, the G-code one, you can just right-click, copy, and then scroll down to your drive D. Yeah, it's one of those right-click, click on that, right-click, paste. Okay, and so that's yours. And it might be that on these, there's somebody else's bench left over from last year or something, but you'll be able to tell by the date which is yours, and the printer will bring that up to usually to the top of the list. Okay, so once that's been copied over, we want to then right-click and eject that drive. We want to make sure that we're not in the middle of something still being copied. So let's get out of File Explorer. So here's the G-code's on here. Continuing challenges of 3D printing is if you get finger grease on these, it's not going to adhere very well, and some part it will slide around and stuff. So pretty much before you start, we've got these alcohol pads. I'll just give them a good wash, but that'll dry fast. If you have real adhesion problems, or if you have something that's like has little tiny, very small areas of contact, we can use glue sticks just to rub on there, and it'll stick better. It'll make it a little harder to get off, but it won't slide around. And there's a glue stick over here in each box, and the glue stick washes off with soap and water if you need it. Anyway, so here we are. They've got a dip here that fits around the two little lugs back there, and the switch is back here for the whole thing. That's the power supply. And when you put this in, it's neatly aligned it sorts the files like an ancient interface. But you scroll down till we get to bench. That looks like our bench right there. So once you get it, you just hit the button, and it will do a couple things. It will start to warm the bed up to, I forget, it's all in Celsius, so who can tell? warm, and then there's a little nozzle in here that it's going to heat up hotter than boiling. So you want to keep your fingers out of there. It might ask you to check to clean the nozzle. You sort of quickly do that. But it'll once those temperatures come up, it'll just start printing. And let's just try to keep each printer's stuff in its own box. So first it does a little test. It sort of locates points to understand where the thing is. And if for some reason one corner is a little high, it will adjust for that and skew all its height measurements by that little tiny amount. It comes over and sort of lays a test bead along there outside, and then starts drawing one of those. Oh, this is called a skirt, sort of around the outside of it. You probably saw that on yours. And it's really just it's another little warm up to get the stuff coming out at the right consistency. And so it's filled in one of the benches, one of the things, and it's now just going back and forth to fill in that first bottom layer. Then it'll do the other two the same way, and then come back and do the first one and doing the second layer of that. For the first week or so, I was just like this the whole time. Such magic, you know. It pales eventually.